Good afternoon, everybody. It's officially afternoon, so I can say that. My name is Patrick Conley. I'm a principal software engineer with Red Hat, and we're going to talk about everybody's favorite topic today, code coverage, and getting your code coverage to 100%. You've probably seen this slide before. I'm not really going to talk about it because I'm not making any forward-looking statements, so let's go. One thing, you should already have signed up for this, but just a reminder, at 1 p.m. upstairs, there's the developer keynote. Go to it. It's going to be good. Unfortunately, you won't miss my talk. So let's start with the basics of why we should test. I know a lot of people say, I test because I have to. Salesforce makes you put in tests to be able to deploy to production. That is a terrible reason to test. You should be testing because you don't want your stuff to break in production. You don't want your stuff to break when somebody makes a change. Now you think, well, I'm going to make a small change. I don't need to worry about tests. No, those small changes are the ones that you got to worry the most about. If you got a small change in a deep utility class, it can have knock-on effects way up the line and break something you don't even know. So if you're testing all of your functionality and you're writing as many tests as you can to cover as much of it as you can, you're going to notice these failures before you get to production. You're going to notice them early. So that's why we test. So as a review, what makes a good test? Well, first and foremost, you always want to be generating your data in your tests. This has become very common now. Used to be all your tests would read data from your production org. For now, it doesn't if you're at a newer API version, but unless you absolutely positively know you have to use CL data, don't do it. If you don't know what CL data is, great, just ignore it. Don't even pretend you know about it. Use start and stop test with every one of your tests. This is important because it resets your limits. When you do a start test, that starts your limits back at 0, and then when you do stop test, it resets your limits. So that way your setup and your asserts and your testing actually don't affect your limits. So you're testing in real world conditions as this is how a user is going to interact with it, and that is how my transaction is going to happen, and I'm going to make sure that I'm within my limits. Also, if you have a bunch of setup stuff, that could starve limits from your actual test. Also, things like future methods and other process-based things don't kick off until stop test, so you need to have them sometimes anyway. My biggest one, if you have any takeaway from this entire talk, it is this. Always have meaningful asserts. Just having assert true in your test is worthless. Pull back data, make sure your code is doing what you expect, and you're asserting that it's actually doing what it expects. And then don't ever do no-op or null operations in your code. That'd be like having a bunch of I++ lines to try to get your code coverage up higher. If you do that, Chris Peterson will find you and he will publicly shame you. And if you don't know who he is, that's probably a good thing. So one of the greatest things you can do for your code and for everything to get your code to 100% code coverage is to prep your code. It's not about writing tests. You have to write the test, but if you can make your code as simple and clean as you can, that's going to make testing it easier. So what we're going to look at is how to reduce what's called cyclomatic complexity. That is code that has got lots of levels deep, and it's got lots of forks and branches that it can go into. If you can reduce the depth of your code, the number of times you have to indent, that makes it testing it easier. So let's take a look at a piece of example code here. So this is a trigger that I wrote. It's kind of really, honestly, a dumb trigger, but it shows the point very well. This says, if I have a status and it is changed from one status to another, I want to set the internal status to something else. So if it's now internal, if the now status is waiting on support and it's changed, I want to set the internal status to waiting on support. Same with waiting on customer. And then if the status is now closed, I want to send out a survey. So if we take a look at this, we can see we have lots of duplicated lines. We have the yellow lines that are the same that both check to make sure that we have it's in the old map. We have a line that's very similar. We're checking the status. And then we have another line that's the same of we're checking or we're comparing if the status has changed. And then we have where we actually set the status. So we can take this code and clean it up a lot and make it into smaller bite-sized pieces. So we have a, is waiting on support. We can check that. We have a is waiting on customer. We have a has the status changed. I will say, don't worry about trying to take pictures of all this. I'll have a link at the end. All this code is up on GitHub. It'll all be there for you. So now we can say we want to set the internal status. We can have our code. Look, if you see here, we're not going a single tab deeper than one. We're going into single if statements. So we say if it's waiting on support, then we're setting the internal status to waiting on support. If it's waiting on customer, we're setting it to waiting on customer. And then we have our add survey. And then now we're inside of our handler is much smaller, right? We're iterating over each method or each object, setting the status, and adding a survey. So now, what does this look like when we test it? So now we have a bunch of tests. And actually, I am getting ahead of myself. So now that we've got our code cleaned up, we want to plan our tests. A lot of people don't spend enough time doing this. If you've done it a lot, it becomes second nature. But when you're starting out, take time to plan your tests. There are 4 different types of tests that I like to plan for. That's a positive test. That is, the code is doing exactly what it should do. So in our example here, we're changing the status, and we make sure that the internal status comes back correctly. We have a negative test. Whatever is supposed to happen doesn't happen. So in our example, we don't change the status. What happens? If the status doesn't change and we just update another field, we don't want that internal status to change, so we need to test that. And then we have our single test where we're just updating a single record, and then we have a bulk test where we're updating several records at once. Now, if you plan every one of your triggers and every one of your code to work on a bulk scale, you'll never be disappointed. I can't count the number of times where I have this trigger never will ever update it in mass. I'll never do data loader on it. And then I'm eating crow because I had to do it and it hits data governor limits, or I've broken something because it's expecting a single object and I didn't ever plan for it for bulk. So if you plan for bulk and write tests for bulk up front, you'll be good to go. So let's take a look at the tests. So we've got one of our positive tests here, and now we're just testing a single thing to make sure, is this waiting on support? We're getting our waiting on support object, and we assert that it's right. Great. We have our negative test here. We have one that is closed, and it's not waiting on support. So you can see how these small tests are going to give us 100% code coverage because we're covering one little piece. And then when we get down to more complicated tests, so we want to get down to, let's see. So we have this one. This tests our entire flow. We have one that we're going to insert a waiting on customer. We're going to change it to waiting on support. And then we're going to call our before handler, and we're going to verify that afterwards it is waiting on, the status is now changed to, the internal status is now waiting on support. So this is our full test of our code. And we've got several of these. We've got before, we got waiting on service, waiting on customer, we have our survey one, and then we've got a bulk one where we're taking 3 objects, changing 2 of the statuses, leaving one, we're changing all the statuses, and then we're going to fetch all of our surveys, make sure that all the statuses are set, and then we're making sure that they actually all happen after we run our code. Now, one thing you notice here, asserts don't have to be done after your test. There are great ways to make sure your data is right before your test. So we see here on line 275, we're making sure that our status is empty before we even run. So that way we make sure that our test did the change and not something else. Like if somebody made a change in one of our test utils, our data setup object, and that could in theory make our test just not valid, or we would never know if it was failing. So that's planning. It's something that, again, you don't want to do, but it's something you should be doing. So now I'm sure a lot of you have done that. So let's dive into some advanced testing things. Exceptions. A lot of people have error handling in their code for exceptions, but that's going to be a chunk in that code coverage graph that is going to be missing because you just don't have it. You don't know how to handle that. So it breaks down into two different types of exceptions. You have known exceptions. Those are going to be things that, if you have a DML exception or maybe a string exception, and those are going to be there, you want to handle it. You maybe want to put an error up on a Visualforce page, or you want to just fork your code based off from somewhere else based on that exception. Great, we can test those. But then you've got the unknown exceptions. Those are, I definitely don't want this to fail. This is like customer facing. I don't want this to fail, but I don't have a good way to verify that it actually did fail, or a way to get it into my code. Like if you're just doing a catch exception, just a generic catch, there's not you don't know, I can't make this fail, but if it does fail, I want to make sure that it doesn't get to a customer. So an example of a known exception. In this right here, this is a really dumb example again, but it gets the point across. We have an integer. If it's equal to 0, we're going to throw an exception. If you ever heard of samurai coding, this is that kind of strategy. Return successful or we don't return at all. I'm a big fan of it. So here, if we have a parameter that we're not expecting or a bad parameter, we're going to throw an exception. So to test that, we have our valid test, our known good test, and we're going to call our method, and we're going to verify that the string is what we expect. And then our negative test, we're going to call it with 0. Now, you could just catch that exception and do a system assert true and be done. But you want to do an assert to make sure the message is correct, because you could be getting another exception and not the one that you're actually trying to test for. So here we're getting the message exception type that we want, this bad parameter exception, and we are asserting that the message is what we expect, that non-zero message. And if you notice here on line 24, we are actually making sure that exception actually happens. If you didn't have that assert there, your test would still pass if that exception never got thrown, because it never gets into the catch, and there's nothing to stop it. So if we do a system assert false, anytime it tries to get past that line, if that method doesn't throw an exception, our test will fail. So that way, if somebody went back later and said, okay, now 0 is a valid parameter, they got rid of our error throwing, this test would fail, and we'll let you know that maybe I need to go talk to somebody. Maybe that was there for somebody else, or maybe there is a reason that this test was failing, or it was written. But maybe that's, now times have changed and you just need to clean up that test. But it's a fail safe to make sure that it doesn't actually, fail unexpectedly. Now, unknown exceptions, really common with DML. So here we're going to insert an object, and if it fails, we want to throw an error up to the user on the page. How are you going to test that? Now you could, if you had required fields, you could stick a required fields in there and make it fail that way, but that's not reliable. Required fields change. Maybe you want a different type of error message for required fields versus a different type of error message for just a generic exception. So with a little bit of change to our code, we can make it test the exceptions. So we have a method here that is generate exception for testing. And what it says is, if I'm running in a test and I want to throw an exception, throw this exception. And that's important, especially the is running test, because this way this will never happen in production. This code will never ever execute, because that test is running test only happens if you're running tests. Make sense? So in our risky business method here, we're going to generate an exception for testing. We're going to do our risky operation, and then we're going to catch our exception. So here's our negative test for our risky business. We're going to set that static variable to say true. We want to throw an exception for this test. We're going to call our method, and then we're going to assert that we have a message in our page, and that message equals what we expect it to equal. Now, one of the other difficult things that is hard with testing is testing now. If I am in a test and I say, or in my code, I say datetime.now and stick it in a field on an object, or I'm using it somewhere else in my class, at the top of my test, that's now, but later down, that's not now. That's then. So when is now? So this one is a really kind of simple thing. So here we have a custom field that is last public update, and we're going to set it to now. So in our modified code, we're going to use a static variable, and we're going to do a little lazy loading here. If we get now and it's not set, we're going to set it to datetime.now, and then we're just going to return now. And then we update our method to now refer to the now variable. Now what this allows us to do is in our test, we can set the static variable. So now I'm going to set it to a known date, a known date time, it's going to be July 29th, and I'm going to set it in my class, and then I'm going to call my setUpdate method. And now I can assert that it is actually that now variable, that these dates are the exact same. I don't have to worry about doing a assert that it's less than the current now, or assert that it is actually set. I can verify that it's the exact date that I set, and it's exactly what I wanted. This is really useful if you're doing modification dates. It doesn't work so great, or you can't really do it on the system modification dates, but on custom dates and things of that nature, it's really great because you may have a test that you want to make sure it gets updated. Well, if you're doing it in a test, those tests run really fast, and sometimes they may not actually have enough time to change the date. So your assert won't necessarily work. So like I said, here is the example code. It's up there on my GitHub. I will also be posting the PDF slides to the chatter page for the talk you can do there. And I also have a blog post on testing strategies if you want to kind of read about a little bit more in depth about how to plan out your testing. So we have a couple minutes if there are any questions. I believe they have a microphone. I don't know if we have a mic runner. If not, you can speak up loudly and I can repeat it and talk it out. Okay. Yes. I can't hear you. I'm sorry. If we don't get a mic, if you want to just meet me over here. Anybody, if you don't want to raise your hand and ask a question, we have this right here in the green jacket.
Green jacket?
Oh, it's gray.
Gray, just kidding.
Man.
How would you do a test for future statements?
For future statements, that's a great question. Again, like I said, with the start test, the future statements don't actually happen until you do a test.stop test. Once you do that, all the queued future statements will run, and then you can do your queries or whatever to get the data to make sure the future statement actually occurred.
And what about APIs? If you're using an external API.
Using an external API, if you're doing that, I believe you'll just have to do the standard mock functionality with I forgot what it's called, where you can mock out an API, and then it'll use that as well, and the future call will finish when the stop test happens.
What's your recommendation for inserting test records to work with?
Okay, so again, what's the recommendation for inserting test records? We have a big test utils class that we try to make it as simple to do. So we have a get account, and then in the test we insert an account. Then we get a contact, and we pass in that account record, and we try to pre-populate it. And we do those as many times as we can. We have bulk methods that's like get case, and then it takes in an account in an integer, and we create that many cases and then return them. So we try to our tests try to have as very little actual creation in them, and we try to do those all in utility classes so that they're standardized. And if we have, like for example, a new required field on an object, we don't have to go through every single case or test and change that required field. We just have to add it to our test utils class.
Do you have a strategy for mocking external objects?
No.
Can I show you the one that I developed?
Sure. So I'm out of time. You guys have been great. Thank you for the questions. If you have any others, you can meet me over here, and I'll try to help you out. Thank you.